For lesson 2, we're going to do a little more, or I guess lesson 2.1 part 2, we're going to do a little more exploration with vertex form and standard form and kind of migrating between the two formats. It'll be a little challenging on the algebra side of things, but again, we're going to continue with identifying these key features of these quadratic functions and migrating between vertex form and standard form. This is kind of the way that we typically see quadratic functions written, as f of x equals ax squared plus bx plus c. Identify your a, your b, your c. We use that for like the quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4ac over 2 times a. The axis of symmetry, the opposite of b over 2a, we're going to use that today. And of course our vertex form, which we're already quite familiar with from the last unit and the start of this unit. So finding the vertex and the intercepts. I'm going to show you that when we're working in the vertex form, finding the vertex is easy, but finding the y-intercept is, I want to say tough, but it's just going to require us to do work. And so the vertex is easy because it gives it to us right here. We've got 4 and negative 25 as our h and k, so that is done kind of in an instant. But to find the y-intercept, we have to substitute x equals 0. And then we're going to have to do a little bit of math, some computational goodness, evaluate this expression, follow the order of operations. We have negative 4 squared is going to give us 16, positive 16. Negative 2 times 16 is going to give us negative 32. And then negative 32 minus 25 is going to be negative 57. And so the y-intercept is 0, negative 57. Doing that computation is not supposed to be that difficult, but it is work. It is work, and so I don't want to deny that there is effort that has to take place and there is work that has to be done. On the flip side over here, the vertex is going to be tough, is going to be work, right? But the y-intercept is going to be easy. And here's why the y-intercept is going to be easy. The y-intercept happens when x is equal to 0. So if x equals 0, f of 0 is going to be 1/4 times 0 squared plus 6 times 0 minus 7. Well, 0 squared is 0. 0 times 1/4 is 0. 6 times 0 is 0. So now you have 0 plus 0 and then minus 7. So f of 0 is equal to your c value. So your y-intercept is, here's your shortcut, 0, c. In this case, that's 0, negative 7. The vertex, like I said, is going to require work. It's going to be 2 parts. The first part is we got to find h. And then after we find h, then we have to find k. And so this is going to require, again, some steps. H we find by taking x is equal to the opposite of b over 2a. We've already identified that a is equal to 1/4, b is equal to 6, c is equal to negative 7. And so x is going to be the opposite of 6 over 2 times 1/4. So we end up with negative 6 divided by 1/2, which is going to give us negative 12. Negative 12. And you can confirm that if you use your calculator. Negative 6 divided by 1/2 is going to give you negative 12. Yay. All right, so when we find k, k is f of h, which means that we will substitute this value from our vertex into this function. 1/4 times 12 squared, negative 12 squared, plus 6 times negative 12 minus 7. And we're going to type that into the calculator or your grapher exactly as it's written. All right, so we are going to take 1/4, negative 12 squared. We're going to add 6 times negative 12, and then we're going to subtract 7. And it gives us negative 43. Negative 43. So I know that this is going to equal negative 43, letting the calculator do that work. So folks, this is not hard, but it just takes effort. We want to make sure that we recognize which parts are easy and which parts require work, depending on the format. All right, next. we want to be able to, so that was review. That was stuff that we did back in Algebra 1 and some stuff that we did this past unit with identifying our intercepts and our vertex. The standard form stuff we haven't done since Algebra 1, I'm guessing, though. The vertex form stuff we've been doing. Given the vertex and a point, find the equation of the function. Find the equation of the function. Okay, so here we're going to take our vertex form, and we know what h and k are. We have a random x comma y, right? There's one there, there's one here, here's one, there's one, and we can probably predict what our stretch is. We can tell that it's opening downward, so we know that a is going to be a negative number. But basically what we're going to do is we're going to find the a value. We've got a y value. We're looking for a. We've got an x value minus the h value squared plus our k value. This equation basically we're taking an x comma y and the h comma k, and we're solving for our a value, our vertical stretch or compression factor, right? So I've got this set up, 5 minus 3 makes 2. I'm going to square that, and I get 4. So now I have negative 4 is equal to 4a plus 4. To solve this equation, I'm going to subtract 4 from both sides, and then divide by the coefficient of a. Now, if we were predicting what this a value would be, we could see that instead of going over 1 up 1, we went over 1 down 2. So we know that our multiplier is going to be negative 2. It's going to be negative to flip it, and it's going to be a factor of 2 on that stretchiness. So once we've got a, we can then write our equation. Y equals a times x minus h squared plus k. This is our equation in vertex form. Yep, I actually have this all written out. Isn't that amazing? Look at me doing all that work. Given the vertex and a point, write the equation of the function. I would love for you to try, and again, this is you try. If you don't know how to do that, watch that last video and try. Rewind the video, watch that last example, and you try to do it. All right, give it your best shot. We'll go over it in class. You guys know that I'll always do that for you. All right, converting to standard form, or from standard form. So given standard form, write in vertex form. If we're going to do that, then we need to know our a value. Okay, that's done. We need to find h, and we need to find k. So really, we need to find the vertex, because we already know what a is. So let's find the h value by taking the opposite of b over 2 times a. This will give me 70 on top and negative 14 on the bottom. That will divide to give me negative 5. Let's confirm that in the calculator. 70 divided by negative 14. Oops. 70 divided by negative 14 gives us negative 5. Okay, good. So we did that correctly. And then to find the k value, we're going to plug in negative 5 here and here to find out what that expression is. So again, we're going to use our calculator. Let the calculator do the work. All right, so we've got negative 7 times negative 5 squared minus 70 times negative 5, and then minus 169. This is why calculators are helpful. It'll do that in a heartbeat. Oh, I got out 6. So the output there is positive 6. The vertex is negative 5 comma 6. So y equals the a value times x minus the h value squared plus the k value. We have written our equation in vertex form. Now, a way to check that to make sure that we did it correctly is to graph the original function in standard form and the vertex and the second function in vertex form, and they should be the same exact equation. All right, they should produce the same exact table of values, and they should produce the same exact graph. So let's find out if Mr. Hibbett can put his money where his mouth is. Let's find out what happens here. X plus 5 squared plus 6. So I'm going to graph both of those. Let's look at the table. Are they the same? Oh, they're the same. Isn't that amazing? So I'm not going to make it graphic because that would just take too long. But there you can see that our answer matches the original graph. What am I going to have you do over here? I'm going to have you try it, all right? So sometimes when I say, hey, you go ahead and do that, you're like, well, I don't know how to do it. Well, but you know how to try. You know how to try. So do this work from Algebra 1, plug that in from Algebra 1, and then write this from Algebra 2. All right, but you try to do letter B here, and I'll move on to the next thing. Converting from vertex back to standard form, and this is where we get to do some multiplication. Because we have to follow the order of operations, and that can be a challenge for folks. So we have that our function is equal to 2 times x minus 3 squared. That means I'm going to multiply x minus 3 times itself. X minus 3 squared is not equal to x squared plus 9. That's not how that works. When we multiply this, we're doing double distribution. Double distribution. So we get f of x is equal to 2 times x times x times negative 3, negative 3 times x, negative 3 times negative 3. So that means I've got 2 times x squared minus 6x plus 9. I've got to distribute that 2 to get 2x squared minus 12x's plus 18. And then I get to subtract 3. I'm going to follow the order of operations. Follow the order of operations. I know that my handwriting is terrible. Slow that down if you need to. Play it back if you need to so you can see each of those steps and how they happen. But what I'm going to do with my grapher is I'm going to take the original function, which is 2 times the parentheses, let's see, x minus 3 squared, and then minus 3. And then I also have y is equal to 2x squared minus 12x's plus 15. And let me check my table to make sure that those came out correct. They're the same. All right, so I have written the standard form of this quadratic that I was given in vertex form. What are you going to do over here? What are you going to do over here? You're going to try it. Try it. Give that one a shot. Let's see how you do. All right, let's see what you got going on there. And that is going to bring this lesson to a close. The practice that we're doing there is a little more time consuming than the last set of work that we do. It's a short video, but there's a lot of practice in there that you're doing. You're doing 3 items on your own, and so give those your best shot. See me in seminar with any questions.